In this video, I'm going to talk about multiplying decimals using a problem that can occur in everyday life. So suppose at your part-time job you earn $7.30 per hour and you work for 2.5 hours. How much money do you earn? A good idea is to do a quick estimate in your head when you are multiplying decimals, and there's also a lot of times where you just want to do a quick estimate in your head, and that way you can compare that with your calculated answer to see if that makes sense. So one way to estimate $7.30 times 2.5 is to use rounding. So 730 is very close to 7, and 250, or 2.5, sorry, is very close to 3. So 7 times 3 is 21. So hopefully by the end of our calculation we should get something somewhat close to 21. So now we're going to do the calculation. When you're multiplying decimals, the decimals don't really matter at first. So we're just going to pretend that we're going to multiply this problem without decimals at all. So we have 5 times 3 is going to be 15. Carry the 1. And 7 times 3 is 35. Plus 1 is 36. Then we have to put our placeholder 0 here. Now we're doing 2 times 3. It's going to be 6. And then 7 times 2 is going to be 14. So just like you would do it without decimals, that's what we're doing. So 5 plus 0 is 5. 6 plus 6 is 12, carrying the 1. And now we have 7, 8, and 1. So now we have this 1008.25, but then we have to remember that we have some decimals here. And so all we do is we count the amount of numbers after the decimal in all the numbers that we're multiplying. So in this case, we're multiplying two numbers, so we're going to count this one here and this one here. So we have two numbers after the decimal. And so what we're going to do is, starting at the end of our number here, we're going to count two spaces to the left. 1, 2. And our answer is going to be 18.25. So I'll just write that up here, 18.25, and we're talking about money in this case, so that's dollars. And is that close to 21? That's pretty close to 21. Something that would not be close to 21 would be 182.5 or 1.825. But 18.25, now that's pretty close. Let's do another example, and I'm going to use a different amount of decimals on the outside, so we get an idea of what that looks like. So let's try something like 1.45. This will be example 2. 1.45 times 2.6. Okay. Now notice, unlike addition, I am not lining up these decimals. It doesn't really matter, because remember, the first thing we're going to do is just multiply it like there was no decimal anyway. So we don't need to line them up. So 6 times 5 is 30. Carry the 3. 6 times 4 is 24, plus 3, that's 27. And then we have 6 plus 2 is 8. Placeholder 0. 2 times 5 is 10. Let me get rid of these. We've already used those. Okay. So now we have 2 times 5 is 10. Carrying the 1. 4 times 2 is 8. Plus the 1 is 9. And then 2 times 1 is 2. As I'm almost finishing this problem, I realize we forgot to do our estimation. So we might as well do that right now. So we have 1.45 times 2.6. Well, 1.45, let's round that down to 1. 2.6 will round up to 3, so we're hoping to get something near 3. So now we can finish the problem. So 0, 7, we have 17, and we have 3. So just using our estimation, we can assume that the decimal is going to go right here. But let's just double check using what we talked about earlier. So count the number of numbers after a decimal place. So we have 1, 2, and 3, which means we're starting on the right. We count in 1, 2, 3 to the left. So that's right, 3.77 And a 0 after the decimal on the end of a number can be dropped off. So we're just going to say equals 3.77. And so that is another example of multiplying decimals. The next thing I want to talk about is mental math with decimals. And when we're doing mental math, we want to keep two things in our thoughts here. We have the commutative property or commutative property. And the commutative property says that any number, so 2 times 3 for instance, is the same thing as 3 times 2. And just to prove it, we have 2 times 3 is 6, and 3 times 2 is also 6. So it basically says it doesn't matter which number's on the left or right, it'll always be the same thing. The associative is a little different. I'm just going to pick 3 numbers. This works with any 3 numbers, but I'll just use small ones to make it easy. 2 times 3 times 4. Okay. So what the associative property says is normally we do multiplication left to right. So we would do 2 times 3 and get 6. Times 4 would get 24. However, the associative property tells us it doesn't really matter if we do it left to right. We could do these two on the right first. 3 times 4 is 12. And then multiply the 2 later. And we would still get 24. You can try that with any 3 numbers, and you'll find that if everything is multiplication, it doesn't matter the order that you multiply it in. So using these two properties, we can do some mental math here. So I have 3 numbers, and mentally, I know that 0.25 and 4 go together really nicely. We call those compatible numbers. If you think about it like this, 0.25 is like a quarter, and 4 quarters would make $1. So the first thing I'm doing here is I'm commutating the 3.58 and the 4. Let me split screen that so you can see what I'm talking about. So, oops, let's go one more. All right, here we go. So actually we can start with the associative property. So I'm first saying, hey, let's group these two, or let's do these two first. And then the commutative property is saying, well, I can change the order of those. I can put the 4 in front. And then using the associative property, I can say, well, let's do these two first. And I know that 4 quarters makes $1, so 4 times 0.25 is going to be 1. And then times 3.58, that's real easy because 1 times anything is anything, or in this case 3.58. So that's one way that you can do mental math with decimals. If you find compatible numbers like this 0.25 and 4, you won't always find compatible numbers, and so you won't always be able to do mental math. But when you do, you should do it. And that's it.